Good evening, sir. My name is Arvan Zeklupang from class DE 5B S1, and in this video I'll be explaining the steps of using the Proteus software to finish the work for Lab 4 Power Electronics. Before I begin, here's the completed circuit that I've already done and the results that I've obtained for the Lab 4 work. I'll be doing the same thing again, building the circuit and obtaining the results as shown here. Alright, so right now let's open up a new Proteus project, which I've already done so. And now let's get the components, starting with a diode 1N4148. This is the diode that we need. Click OK. The next component is a capacitor. A capacitor, this capacitor. Alright. The next component is an inductor. For inductor, we'll be using this inductor. And the next component is a MOSFET, or more precisely, IRF 540. This MOSFET over here is what we'll be using. The next component is a resistor. The typical resistor, which is this resistor over here. And the last component is a DC voltage source. Alright, that looks alright. This DC voltage source. And these are all the components that are required. It's time to assemble the components. Starting from USB source. And after that, we will be placing an inductor over here. And let me check for a while if it's... Yes, inductor over here. The MOSFET here. Diodes over here. Capacitor. And lastly, the resistor. Just follow as shown at this diagram. Okay, that looks about right. Next up, what we need is to ground the components. We'll take this ground component over here. Just place it like so. Just like this. Alright, we've grounded all the components. The next thing we need is to measure the voltage output. Just gonna place it over here using this DC voltmeter to measure the output of the voltage. What we need right now is the pulse. We need a pulse generator, which we can obtain from here, and we place it like over here. So next up, we're going to adjust the values of these components over here as required at the lab sheet. First of all, the value of this DC voltage source, check it again, 50 volts. Alright, so it's going to change this value to 50 volts. Alright, the next up is the value of this inductor. Let's see. Alright, 400 microhenry. Alright, it's gonna type 400 microhenry. You can also type U. It also means micro. Alright, the next one is the value of the capacitor. It requires 100 microfarad, so it's going to change the value to 100 microfarads. Alright, now for the resistor, 20 ohms. It's going to change this to just type 20 over here, enter, and that's for these components. Next up is the value of this pulse over here. And first of all, it's going to change the generator name to PWM. Once that's done, I'm going to change the values over here. The low voltage initial starts at 0, and the pulse high voltage, I'm going to set it to 15. And the rise and the fall time, I'll set both at 100 nano. Alright, same for the fall time, 100 nanos. And for the pulse rate, I've made calculations, as you can see over here. The pulse rate for this lab is 40%. And for the frequency, let's look at the lab sheet. 20 kilohertz. So I'm just gonna type in 20k. Alright, now all that is done. Let's run the simulation. Okay. Alright, the volts jumps from 77.7 to 82.3. Now let's run the simulation on the circuit that I've completed before. Alright. So as you can see, it's the same thing. 77.4 for this one. Highest one is 82.3. It's similar as what we've done just now. So simulation runs great. Alright, it's good. Okay, so right now what we're going to do right now is to obtain the results in the form of both of these graphs, which shows the output voltage and the output current. So what we're gonna do right now is to go over here, the probes, and take the voltage probe, place it over here, and the next up is the current probe. Once that's done, we're just gonna rename this first, just like that, and then this one, so it's more easy to identify later in the results. Okay, the next step is to go over here, the graphs, and click on this analog, and just drag. Click first and drag to make a box. Make two of them because we need the voltage and the current, so we need two boxes. Alright, what I'm going to do right now is to drag either one of these, current first or voltage first. It's either way, it's fine. First thing I'm going to drag is voltage. Let's drag it over here, and same thing for current. Alright, so let's right click over here. For the start time, leave it 0. For the stop time, make it become a 10 milli. Alright, or resimulate, yes please. And there's the output. This is what we need. Okay, voltage is done. Do the same thing for the current. Set this to 10 amp. Alright, do the same thing, resimulate. Okay. Right, seems that the results are not really that apparent whenever this happens. Just right click on this, set Y scales, tick this box and refine the values. Let's say just make it come more lower, -1 U. For this one, let's set it to 10. Let's set it to this value. Okay, resimulate. You almost got it. It's gonna need to make it come more smaller. I'll just set the minimum that. Let's say 5. Okay, resimulate. Alright, just a little bit more for mine. If I have the result for yours really that apparent, it's fine. So you could just leave it as it is. But for mine, I have to just change the values until the results come obvious. Alright, okay. Alright, so these are what you should obtain for lab sheet. And that ends my explanation of using the software Proteus to finish up the work for the lab 4 power electronics. Thank you for watching.